Okay, Chem Accel. We are going to go through heat calculations. All right, for those of you who still have some questions about setting those up, which equation to use, or if there should be a negative involved. All right, so I have up at the top here, you can see just the little cutout from your reference table, and that way we can just reference things from acetone up here as we go. All right, this will help show how to use the table up here as well. Before I start with setting up the calculations, let's just make sure we know what some of these words mean. Like fusion here is going to be solid to liquid, solidification, liquid to solid, okay? Vaporization, liquid to gas, and condensation, gas to liquid. Because I know some people have been having a hard time keeping a couple of those words straight, especially with fusion in there. That's weird. All right, so now we've got those defined. Let's go ahead and get started with the calculation down here. All right, so the first one, we have how many grams of acetone can be heated from a negative 100 to 0 degrees Celsius when 5,000 calories are added. All right, so we have our Q already in this case being 5,000 calories. And then in terms of setting up the calculations that go with each of the three segments up here, all right, because we have three segments, all right, we're going to go ahead and, since we don't know the mass, just write M 3 times. Because every equation starts with mass. All right, the next part of the equation is going to be something off of your reference table. So if we look at the first segment here, we can see that we have a solid. So I'm just going to look up the word solid, and we've got 0.54 calories over grams degrees Celsius. So write that down. Okay. For the next segment, we have solid to liquid. So that would be up here. Solid to liquid goes with heat of fusion. So if we go down to that value of 23 calories per gram. And then our last segment here, all right, is we have our liquid. All right, so if I go find liquid, all right, we have our 0.5 calories per gram degrees Celsius. All right, now one of these calculations is already done, and that's the middle one here, because we have grams is the only thing on the bottom, and when we have a mass here, that mass will be in grams, and that grams will be able to cancel out, and we'll be left with just the calories. These first two equations, however, we've got grams and degrees Celsius on the bottom of these, and that's because these are the MC delta T equations, right? C being the specific heat, right? C, just a reminder there, okay? And we do need the change in temperature. So if we go back to that first segment here, it's going from negative 100 to negative 96.6. So if we do final minus initial, we end up with this for our temperature change. I know some of you don't like that double negative there, but it is what it is. All right, then this last one went with the liquid segment here, right? So that one ended at 0, started at negative 96. Okay, so we're making sure we just do final minus initial for that individual segment. And that's our whole setup here. In this case, this would be now an algebra problem, all right, of grouping like terms and solving for M. All right, over here with our second question, we have a cooling curve. So there's a little nuance in here that I want to make sure everybody, all right, gets the point for. And if we look at this when we're calculating energy, so we're going to calculate Q, and then we're going to start these off the same way. We have 6 grams of acetone vapor cooling until frozen. So because we know the mass, we're going to go ahead and put 6 grams, doing it 3 times because this graph has 3 segments. Not every graph has 3 segments. Just set up for however many segments you have. All right, the next number should be something off the reference table. So if I look at this one, we have gas to liquid. All right, if we go up top here, we find gas to liquid for condensation. Now the nuance here is that fusion vaporization, solid, liquid, gas. Those are the first words at the top of their columns. Those values are going to be positive because you put energy in, okay? When you use the specific heats, if energy is coming out, you'll end up with a negative delta T, as we will see. All right. However, the second words up here, solidification and condensation, all right, that's where we would stick a negative on these values. So right here, when I'm going from gas to liquid, and that's my condensation, I'm going to have to use negative 125 calories per gram. Right? This segment, we have liquid. Liquid's the first word at the top of this column. It's the only one there. So when I put that 0.50 calories per gram degree Celsius, I'm just going to leave it positive. And then here I go liquid to solid. That's solidification. Again, that's the second word, so I'm going to put a negative on that 23 calories per gram. Okay. All right, and then last bit here, again, this one's got that degree Celsius on the bottom, all right, in the middle equation here. So I am going to need that temperature change. In this case, we are ending at negative 96.6, starting at 56. So we were final minus initial. So this one will become negative because of this value right here being negative. So each of these individual calculations, all three of them, they each come out to be negative. Your Q is going to be some negative number of calories. And then you'll be able to just write down, reiterate that, and say that that is the calories lost. Okay, let me know if you've got any questions. All right, I will be available via email, and we'll probably do a conference as well.